Hey there, manufacturing enthusiasts! Today, we're going to explore the world of injection molding. We have provided our article link in the description. Make sure to read it and grab the PDF too. So, let's buckle up, grab your notebooks, and get into the video. In 1872, John Wesley, an American inventor, introduced injection molding. A machine worked like a hypodermic needle, injecting hot plastic into a mold cavity. Fast forward to 1903, the game changed with the discovery of cellulose acetate, paving the way for new possibilities. Now, what exactly is injection molding? It's a well-established manufacturing process utilizing a machine to inject materials into a mold. This process demands substantial force to create finished products meeting precise specifications. And with today's designs and materials, it's become a powerhouse for efficient and rapid large-scale production. Let's unravel the parts of an injection molding machine, where each component plays a pivotal role in crafting molded wonders. It all begins at the hopper, our stage for loading the plastic ingredients. Enter the Archimedean screw, gracefully propelling the material forward. The heaters join the performance, their job melting plastic polymers to the perfect consistency. As the material steps into the spotlight at the nozzle, it reaches a temperature that ensures a swift entry into the mold cavity. Cue the extraction pin, working harmoniously with split molds to elegantly remove the molded shape. Cooling channels, our intermission, cool and solidify the product. The clamping unit then takes center stage, securing the tool in place. The injection unit, the heart of the operation, injects the mold with plastics. The drive unit, the force behind the scenes, rams the mold into the cavity. And finally, the hydraulic system, the powerhouse, presses and rams the mold, concluding the symphony of injection molding precision, efficiency, and the creation of wonders. Now, let's walk through the injection molding process step by step. From feeding material into the hopper to the Archimedean screw pushing it forward, and then the heated area where magic happens. The material shoots through the nozzle into the mold cavity, and voila! The cooling process begins, and the extraction pin removes the molded parts. Alright, hold on to your hats because there are 5 major types of injection moldings. We've got metal injection molding, die casting, injection molding of liquid silicone rubber, thin wall injection molding, and reaction injection molding. Each has its own unique twists and turns. Metal injection molding. Ever heard of it? We mix metal powder with a polymer binder to create feedstock. The feedstock is injected into a mold, and we get a green metal part. But it doesn't end there. We've got to separate the metal part from the polymer powders and then singe it. It's like sculpting with metal. Die casting, a process for perfectionists. We press molten metal into dies to get that precise shape. And there are 2 methods, hot chamber and cold chamber die casting. Plus, we use cool alloys like zinc, aluminum, and more. It's like playing with molten metal Legos. Now, let's switch gears to liquid silicone rubber injection molding. Durable material parts. You got it. It's like the superhero of molding when you need toughness and flexibility. Thin wall injection molding, the unsung hero for making those thin plastic parts. It's not just cost-effective, it's the go-to method for industries like food packaging and medical equipment, because sometimes less is more. And here comes reaction injection molding, where 2 materials mix at high pressure and get injected into the mold with low pressure. It's like a chemical dance resulting in the perfect product. Now, let's get into the nitty-gritty. How does injection molding differ from compression molding? We're talking about material placement, pressure requirements, mold design, production volume, cost, and surface finish. It's the battle of the molding techniques. Wait, it's not all sunshine and rainbows. Injection molding has its quirks, and we call them defects. Flow lines, burn marks, warping, you name it. But fear not, we'll guide you through the maze of imperfections and how to tackle them. Advantages of injection molding are quick production, minimal scrap, and controlled color are on one side of the ring. On the other, the disadvantages are high tooling costs and the need for careful design. It's a balancing act in the world of injection molding. Now, let's talk real-world applications. From automotive parts to medical equipment, electronic components, consumer products, and even aerospace components, injection molding is everywhere. It's like the unsung hero behind the scenes. Now, let's answer some common questions our folks have. The very first question is, what are the various types of injection molding products? Well, it's highly versatile from toys to medical equipment. It covers it all. Secondly, what are the various types of injection molding defects? Defects like air traps, flash, and sinking can occur, but proper maintenance and monitoring can prevent them. And that's a wrap, folks. We've covered the A to Z of injection molding, from its history to the various types, advantages, and applications. If you enjoyed this deep dive, give it a thumbs up. And don't forget to comment down below with your thoughts and questions. Until next time, stay curious and keep on manufacturing.